Well, shit. Nothing. Today there's nothing to repair.
留学。
そうです。
留学。ごめんね。
外国人ですか？
外。坂、外。京都。留学。東京。そうですよ。ジョンは留学生です。ごめんね。
ね。
5歳。孟子。外。外国留学。
マリアは留学生です。留学生ですか？はい、そうです。マリアは外国人です。外国人ですか？
そうです。よ。
違いますよ。大学生です。大学生ですか？大学生ですか？
大学生たち。
高校生たち。
年生。高校。住。大阪。孟子。違います。
高校生です。
いいえ、違います。中学生たち。
Oh shit.
違いは何ですか？小学生たち。
大学生ですか？
私は高校に行きます。こう。ナオミ。
What? What does it mean?
ケンタ。
What? This is all new. Is that a name?
ケンタ。
Huh.
ケンタ。
健太は学生です。
Oh, that's a name.
健。太し。健。
ナオミは学生です。時価。美。時価。
健太、
すみ。5歳。高校。ナオミ。健太。ナオミ。健太。外。5歳。大阪。ナオミ。
健太は東京に住んでいます。ナオミと健太は大学生です。ナオミと健太は、ナオミと健太は大学生です。です。
ナオミは京都に住んでいます。
ナオミと健太は大学生です。
What?
隣、
Next to a neighbor.
弟がたくさんいます。
I have a lot of younger brother. Ah,
隣、隣、
あなたの前にいます。
I am in front of you.
椅子はテーブルの隣にあります。
The chair is in front of the table. Oh, next to the table.
隣、
What does it mean? Oh, huh. Hmm.
父は母の横にいます。
Yoko.
横、
The same. What's the difference? That doesn't make any sense. Huh.
後ろに椅子があります。
There is a chair behind.
隣、横、
左.
左、右、上、
横。横。
右、横、上、左、隣、隣に母がいます。
My mother is next to me.
前と後ろには妹たちがいます。前と後ろには妹たちがいます。前と後ろには妹たちがいます。たが、い、ます。
My younger sister are in front and behind me. Doesn't make a lot of sense.
兄はテーブルの横にいます。
My older brother is next to the table.
水がたくさんあります。
There is a lot of water.
たくさん食べます。
I will eat a lot.
あなたの後ろにいます。
I am behind you.
テーブルの横に椅子が一つあります。
There is one chair next to the table.
大きい。小さい。うちの家族は大きいです。
Our family is big.
ベッド。うちの台所は大きいです。
Kitchen. ？What?
机の上に本が3冊あります。
There are three books on the table. On the desk.
本が本棚に1冊あります。
There is one book on the bookshelf.
本が本棚に7冊あります。本棚に本が本棚に7冊あります。7冊あります。隣冊右棚本棚小さいベッドですね。
That is a small bed. It is a
上、
横、
左、
冊、本棚。うちの本棚は小さいです。
このベッドは小さいです。
昨日はうちにいました。
I was at home yesterday.
あのベッドは大きいです。本が本棚に7冊あります。
本が10冊あります。隅、
What?
隅、
Sumi. The corner corner.
あの隅には本棚があります。
There is a book in that corner. A bookshelf.
隅、隅、
この本は長いです。
This book is long.
布団は長いです。
隅、
ベッドは片隅にあります。
A what?
肩、隅、肩、隅、肩、
What's the point?
肩。
Why? Ah.
肩、札、隅、布団、長い、
布団は片隅にあります。
長い、布団、隅、肩、本棚、
彼女の本はちょっと長いです。
Her book is a bit long. What? A little long?
布団の中で起きます。布団の中で起き、布団の中で起きます。
I wake up inside the futon. On what?
そのテーブルは長いです。
布団の中で起きます。新しい、
New.
低い、
近しい、
Ah, shit.
新しい、
That's not right.
古い、
Oh.
テレビ、低い、古いテレビです。
彼のベッドは低いです。
古い。この布団は新しいです。
古い、
Hidari.
左、低い、布団、
That
低い、新しいテレビは片隅にあります。
the television is in the corner.
低い、
上、
古い。隅、新しい。その椅子は低いです。
That chair is low.
このテーブルは低いです。このテレビ
This table is
は、このテーブルは低いです。で
low.
す。
What? Shit! I mistook the table and the TV. Shit!
ベッドは古いです。
The bed is on.
あのテレビは新しいです。ベッドは新しいですか？
Is the bed new?
このテレビは古いです。
This TV is oh,
このテーブルは低いです。
oh.
このテーブルは低いです。このは古い。このテーブルは低いです。
What? Again? Oh shit! Missing, just missing. Why?
このテーブルは低いです。
Shit.
このテーブルは低いです。
Not cool, man. Don't trap me like that. Huh. You ruined my perfect streak, man. Kagami.
鏡。
冷蔵庫。あの冷蔵庫は新しいです。
Mhm.
古い。隣。鏡。新しい冷蔵庫。
新しい冷蔵庫です。
What is a new trick? Yoko.
横。
Kagami.
鏡。右。本棚。冷蔵庫。
鏡は古いです。
The mirror is on.
この鏡は高いですか？この鏡は高いですか？
Is this mirror expensive?
鏡は新しいです。
The mirror is what? New.
布団は鏡の下にあります。
The futon is below the mirror. What? That doesn't make sense.
この鏡は高いですか？
Is this mirror expensive?
この冷蔵庫は古いです。
This refrigerator is oh. Next one. I'm not good with direction, man. Big and small. E and na. When 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 do you use E? When do you use na? Why so confusing? I hacked Japanese. Where? Shit.
建物。
The building.
建物。
建物。
Oh.
入り口はどこですか？
建物。What does this one mean? Where is the entrance?
入り口はどちらですか？
The same. Oh, which way? 建物。
建物。
Building.
入り。
Play.
皿。お
Chopstick.
箸。
And the mouth.
口。
Mouth.
出口はどちらですか？
Which way is it? Oh shit. Shit. Oh shit. Oh.
口、
Oh.
皿、入り。建物、お箸。
出身はどちらですか？
Where are you from?
入り口はどこですか？は、
Where is the
その
entrance?
建物はこちらです。
That building is here. It is way. What? So no. What? It should be that. Why is it
そ、
the? That doesn't make sense, man. What? Nothing makes sense. In the end, I really don't like Japanese.
この建物はどこですか？
Where is this building?
出口はどこですか？
Deguchi. Shit. I cannot pronounce it, man. Where is the is it? Oh shit! What? Shit! What a stupid mistake.
この建物には出口と入り口があります。
This building has what? And is it? And that doesn't make any sense. Of course, the exit is also the entrance. What?
建物の入り口はどこですか？
Where is the building's entrance? The entrance to the building.
出口はどこですか？
Where is it? Ay. Shit. Why so little?
銀行、
Ginko. I want to burn the banks, man. They don't
病
do
院に
anything
行き
good.
ます。
I will go to the hospital.
コンビニはこちらです。
The convenience store is this way. The convenience store is here. Sometimes it's here, sometimes it's this way. It's annoying. Over here. What?
どうやって銀行まで行きますか？
Do ya take Ginko? How do I go to the bank?
どうやってコンビニまで行きますか？コンビニまで行きますか？2時にそちらへ行きます。
What? 2 o'clock? I will go there at 2 o'clock. Huh. What a random sentence.
入り、口、銀行、建物、病院、コンビニはどこですか？
Where is the convenience store?
銀行、入り、口。建物、病院。
病院はそちらです。
The hospital is that way.
どうやって病院まで行きますか？
How do I go to the hospital?
どうやってコンビニまで行きますか？
convenience store.
病院の入り口はどこですか？
Where is the hospital entrance?
銀行の出口はどちらですか？
The Where is the bank is it?
銀行はどこですか？
Where is the bank?
そちらの入り口からどうぞ。
What? From that entrance, please. Oh,
うど、
what?
コンビニはここです。
The convenience store is here. Shit, why so little?
店、
あなたのお部屋は向こうです。
Your room is what? Is on the other side? Oh, your room is over there.
向かい、
Huh.
向かい。
What?
お店はあちらです。
The store is over there.
コンビニを出ます。
I will go to the convenience store. What? Oh, is it the convenience store?
道は向こうです。
The road is ahead. What? Over there. Building.
病院、入り、道、向こう、店、病院を出ます。
I is it the hospital.
口、店、向こう、道、建物。どうやってこのお店まで行きますか？
How do I go to this store?
道は向こうです。店、
Oh, 道 not
道
Mr.
は向こうです。道は向こうです。コンビニは向こうです。
The convenience store is over there.
道は長い。
The road is long. What?
お店はそちらです。
銀行はあちらです。
The bank is there. Maybe over there.
コンビニはあちらです。 通り。はじめに、建物を出ます。
First, is it the building?
通り。さあ、降りましょ
What? Well then, let's
う。
what?
こう。さあ、降りましょ
What?
う。こう。
The hell is this word?
さあ、降りましょ
The hell?
う。彼らは大きな家に
彼
住んでいま
Oh,
す。
I should have just copied the word. They they live in a big house.
通り。向こう。病院。銀行。道。
小さな病院。
Small hospital.
会社に入ります。
And the company, the office. Huh.
階。
Oh, either way, fine.
はじめに、小さな銀行のそばを通ります。
First, you pass the small bank. You pass by a small bank.
通りはあちらです。2.
What?
通りはあちらです。
The shit? Really? Oh,
大きな出口があります。
there's a big exit.
銀行に入ります。
はじめに、大きな病院のそばを通ります。
First, you pass you pass by a big hospital.
大きな銀行。
Big bang.
狭い。広い。
広い。
次。
この病院は広いです。
This hospital is wide. Oh, spacious.
次。
Next,
次の駅で降ります。こう。次の駅で降ります。
what? Why doesn't it
で、
show,
こ
show me, man? What? Huh. Oh, why doesn't it show up here? Oh, I will get off at the next station. No, the next station.
この部屋は狭いです。
This room is narrow. What? Small?
狭い。
Narrow.
そちらをまっすぐ進みましょ
What? Let's go straight there.
う。進む。ま、
進む。Next.
次、
The hell is this?
入り、
Enter.
狭い、
Narrow.
進み、広い。この道は狭いです。
This road is narrow. This path is narrow.
店、
Store.
広い、
Wide.
狭い、
Narrow.
進み、
Advance. Next.
次、
この学校は広いです。
The school is wide. This school is.
次に広い道をまっすぐ進みます。
What?
次に広い道をまっすぐ進みます。進む。
What?
次に広い道をまっすぐ進みます。まっすぐ、ます。
Next, you walk straight down the wide path on the wide road. A grammar question. Not very interesting, man. Who created this question? Finally, I will be free from this soon.
書く。南はどっちですか？
Which way is south?
北はあっちですか？
Is no that way.
南はどっちですか？
みな、
は、どっですか？学校はこっちですか？
Is the school this way?
あそこの角を右に曲がります。
That corner. You turn right.
あそこの角を右に曲がります。
You turn right at that corner.
そっちに曲がります。
Turn there. That way.
入り、
Oh, where the hell is it? Minami.
南、角、広い、曲がり、
こっち、こっち。
Come here.
北、角、向こう、建物、曲がり、北はどっちですか？
Which way is north?
西はどっちですか？
Which way is west?
すみません、駅はどっちですか？
Excuse me. Which way is the station?
東はどっちですか？
Which way is east?
北はあっちです。
No, is that way.
ここの角を左に曲がります。
This corner. Turn left at this corner.
学校はそっちです。
The school is there. What? That way.
どっちですか？
Which way is it? What? Which one is it? Which is it?
東はあっちです。
Is it that way?
上げ、
What? Try.
唐揚げ、
The hell does this mean? What?
唐揚げ、唐揚げ、
Fried chicken.
おにぎりをお願いします。ガン、
What? Please. A rice bowl, please.
スープを温めてください。
Please heat up the soup.
オン、
Oh.
唐揚げ。唐揚げを買いました。
I bought fried chicken.
スープを温めました。
I heated up the soup.
揚げ。コンビニで唐揚げとフライドポテトを食べました。ら。コンビニで唐揚げとフライドポテトを食べました。
Fried
ポ。テ。ト。
potato.
ポト。
I ate fried chicken and fried French fry at the convenience store. The hell?
揚げ、温め、唐揚げ、菓子、
The hell does that mean? Where is it? It's not here.
袋。
A bag.
どんなおにぎりが好きですか？
What kind of rice ball do you like?
菓子、
What the hell does it mean?
唐揚げ、揚げ、袋、温め、コンビニでおにぎりを4つ買いました。
I bought 4 rice balls at the convenience store.
こちらは温めますか？は、こちらは温めますか？温め。こちらは温めますか？
Will you heat this up? Would you like this instead? Okay. Not what I thought. Reset.
レシート、
Despacito.
お持ち帰りですか？
What? What the hell is this?
き、
Will you take it home? Oh,
持ち、ち、き、り。
窓を開けてもよろしいですか？
Open the window and then what?
も、よ、ろ、し、で。
May I open the window? Another form of sentence that I don't know and don't understand and don't like.
も、
The hell is it?
よ、ろ、し、い。
果物をどうぞ召し上がって。
What?
飯。果物をどうぞ召し上がって。
ぞ、
飯。
Again and again.
上、
Have yourself to the fruit. I still don't understand.
持ち帰ります。
I will take it home.
レシートはよろしいですか？
What? Do you want to take the receipt? Would you like a receipt?
よ、ろ、し、い。
ここで召し上がりますか？
What the hell is it now?
飯、し、上、が。ここで召し上がりますか？
Will you be eating here?
上、で。
How the hell did it come to this meaning?
飯、
Messi. What? It only mean corn. Why did it become food? What?
が、上。
店内で召し上がりますか？
I'm confused, man. In the store. Will you eat in the store? What? Will you be eating in the store?
どうぞお召し上がりください。
Please. What? Please go ahead and eat. Please enjoy your meal. Nothing makes sense.
店内で召し上がりますか？店内で召し上がりますか？店内で。 店内で召し上がりますか？召し上がりますか？菓子
They still haven't explained what the hell this means.
飯揚げ温め袋レシートをお願いします。
Despacito onegaishimasu. I would like a receipt.
レシートは大丈夫です。
What? I do not need a receipt.
What
does it mean? It literally means a receipt is fine. What? Stupid. Shit. Okay, at least it was short. If it was longer, I would go crazy. The city.
週末はコスプレをします。
I cosplay on the weekend. On weekends.
交差点のそばを通りました。
I pass by the intersection. An intersection.
池袋で映画を見た。
I watched a movie in Ikebukuro. I saw a movie.
地下鉄で池袋までどうやって行きますか？
Stop so fast.
地下鉄で池袋までどうやって行きますか？
池袋
まで
どうやって
地下鉄で池袋までどうやって行きますか？
行き
ますか？
How do I get to Ikebukuro by subway?
新宿のカフェで会いました。
What? We met at a cafe in Shinjuku. Huh. Okay. I can translate somewhat.
馬の背に乗った。
I rode on horseback. On a horseback? What?
地下鉄には多くの人が乗っています。
Many people take the subway. Are riding the subway. 10. What?
点交差点原宿渋谷会場
What? 会場
池袋は賑やかで面白いです。
賑やか lively and interesting. Is it noisy and annoying?
点渋谷原宿種目交差点彼女はコスプレをするのが好きです。
She what? She like cosplay to dress up.
地下鉄で池袋までどうやって行きますか？
How do I go to Ikebukuro by subway?
その交差点はとても危なかったです。
That intersection was very dangerous.
交差点はどちらですか？
Where is the intersection?
この建物は交差点にあります。
This building is at an intersection. 。
交差点です。
Is it an intersection?
その大きな交差点は少し危ないです。
What the hell? That big intersection is a bit dangerous. A little dangerous.
私と一緒にコスプレしませんか？
We I together. Do you want to cosplay together with me? Will you cosplay with me? How about no? Fuck that shit. Shit, why so little? Are you for real? So little, man.
1000
Just a few percent. Sen. It means the railway. Sen. That's not the correct one. Oh, it could be a telephone line. Oh well, whatever.
父はサラリーマンです。
My father is a salaryman. A what? An office worker, and he is never home.
1000
And he is overworked. And he is committing an affair.
1000彼の部屋は庭に面しています。
His room face the garden. Huh.
面
Easy.
通りは人で混んでいます。
What? Hito de. I simply don't understand this sentence at all.
2、
The street.
人、で、混。通りは人で混んでいます。
Konde.
混ん、
The hell does this mean? Huh. The street is full of people. Crowded with people. That doesn't make a lot of sense. Sen.
線、
東京メトロはとても便利です。
What?
東京メトロはとても便利です。
Metro. Very convenient. Okay.
平日は山手線がとても混んでいます。
What? Yamanote. Mountain hand. Totemo. What? Routed. Every day. On which day?
平、日、
The Yamanote line is crowded on which day? Very crowded.
交差点、原宿、渋谷、線、点。彼女の部屋は北に面しているの。
Her room face north.
メトロはサラリーマンで混んでいた。メトロはサラリーマンで混んでいた。サラリーマン、メトロはサラリーマンで混んでいた。で、混んでいた。
The metro was crowded with salarymen.
この建物は海に面している。
This building face the sea. What? Where? What? Look out onto the sea. That doesn't make sense. But okay.
メトロで多くのサラリーマンを見た。
I saw a lot of salarymen on the metro. What the hell are you watching?
東京の電車はいつも混んでいるね。
Tokyo train always crowded, aren't they? I'm not half bad, man. I'm just a little bad. Okay, that's how it's supposed to be.
大阪は大きな都市だ。
It's a big city.
ノルウェーの首都は何ですか？
Norway. Norway what?
首。
Capital. What is the capital of Norway? Copenhagen? I don't know. What's the capital of Norway? Oslo. Huh. Copenhagen. What a different country.
場所を教えてください。
What country is that? Denmark. The hell is this? What? The ocean.
今日
The location.
上、ところ、
Huh.
上、ところ、上、上
They
ところ、
they
上
both mean
ところ
location, man. What? Shit.
この近所にコンビニはありますか？
Is there a convenience store nearby? A convenience store in this neighborhood.
近、とこ
Okay.
ろ。場所を教えてください。場所。を。で、
Please
ください。
tell me the location.
京都の人口はどれくらいですか？
The population of Kyoto. What? What is the population of Kyoto? She,
市、
the city.
市、線、
Harajuku.
原宿、渋谷、交差点。
面白い場所です。
Interesting location. Place.
東京は日本の首都です。
Tokyo is the capital of Japan.
都市の人口はどれくらいですか？
What is the population of the city?
東京の人口はどれくらいですか？
What is the population of Tokyo?
中国の首都は何ですか？
What? Beijing, probably. What? I'm not speaking Vietnamese at all.
近所に美味しい日本料理の店はありませんか？
Isn't there a good Japanese restaurant in the neighborhood?
一番好きな都市は何ですか？
Your favorite city?
場所を教えてください。
Please tell me the location. Mhm.
笛、
What
笛、
the hell is that? Increase.
人口が増えている。
The population is increasing.
笛、笛。広島の人口はどれくらいですか？
Hiroshima. The white island. What is the population of Hiroshima?
お腹が減った。
What? I'm starving.
元、元、
Reduction.
増え、
Increase.
減り、
Reduction.
増え。私の母は銀座に店を持っています。
Ginza. My mother has a store in Ginza.
銀、座、銀、
Silver
座。
City.
銀座線は時々混んでいます。
Often. The Ginza line is sometimes crowded. Sen.
千、点、笛、
Harry.
減り。原宿、都市の人口が減りました。
The population of the city has decreased. Has fallen.
減り、減り。笛、ち。減り。千、原宿。
広島は私の一番好きな都市だ。
Hiroshima is my favorite city.
銀座線に乗った。銀座。
Then
線に、た。
I took the Ginza line.
彼は毎朝銀座線に乗る。
He takes the Ginza line every morning. He ride the Ginza line every morning.
人口が減った。
The population has fallen.
都市の人口が増えている。
The population of the city has increased. Is increasing.
銀座線に乗った。
I took the Ginza line.
都市の人口が減った。 人口
Yeah.
が減った。
That's fast, man.
集まり。
The hell? Collect? Does it mean collect? Oh, yeah.
住民。
The hell is this? citizen,
住民、住民、
スマホ、数、
what,
5時にまたここに集まろ
again, gather here again at 5 o'clock. Huh.
う。集まり、集まり、明日集まりましょ
Let's gather tomorrow. Let's get together.
う。住民の数が増えている。
The number of citizen resident is increasing. Atsumari,
集まり、
gather.
ホテルは広場に面している。
What?
広し、場、
The hotel face the square.
広し。広場に人が集まった。
What? People gather at the square. In the square.
住民。広場に人がたくさん集まっている。
Many people are gathering in the square. Oh, are gathered in the square.
住民。
Where
増え。減り。集まり。線。
住民たちは私に手紙を書きました。
the resident, they have this. They what? They gave me the letter. The resident wrote me letter. What? A letter. This like sound like something from a movie. Huh.
住民、し、集まり、渋谷、交差点、
大学生の数が増えている。
University. The number of university students is increasing.
住民の数が増えている。住民の数が増えている。
Kazu. The hell?
住民の数が増えている。が、増えて、いる。
5 o'clock.
5時
に、ここ。また、ここに。
う
In the square. The hell is that? In the square.
広場。に、
People.
人
が、た、
Second the city. Numbers. Only bracket. Shika. いません。時間 we fly はのに
1回、
one time math
数学、2回、
two
2回
time
私の町では住民の数が増している。
The number of residents in my town is increasing.
12の 50% は6です。
12 what? 12 of 30% is 6.
6、
What? That doesn't make sense. 50%
Ni.
should be in front. What? Japanese silly man. 12 is 6. Japanese stupid. 2
2
times.
回。見ているだけです。
I am only looking.
都市の人口が増した。
The population of the city increased. 火曜日 Thursday
火曜日。す、
マリー
マリー。1回。通訳。
1週間に1回英語を勉強します。
1週間に in one week one time English. I study English once a week. Once per week.
日本語の辞書を1冊しか持っていない。
日本語 I only have one Japanese dictionary. I have only one. What's the difference?
都市の人口が増した。
都市 where is it?
都市の人口。都市の人口が増した。増し。都市の人口が増した。増した。
What? Why is it mashi? I'm pretty sure it's you will to be full. What's happening? It's full here. Why did he say? Why did he say mashi here? What? It's the same word.
都市の人口が増した。
What's the difference? I don't
数
understand.
学。
Math. I don't understand, man. What's the difference?
明日は数学の試験があるでしょ
Tomorrow there's a math exam. We will have a math exam tomorrow. Properly.
う。し、
Okay. Why does Japanese have to
で、
stop
De.
everything at the end? It's really annoying.
数が増した。
The number has increased. Has gone up.
私は1週間に1回先生に会います。
I meet my teacher, my professor, once a week. The teacher once a week.
数学の試験を始めましょ
Math exam. Let's start the math exam. Or what? Begin.
う。この部屋には田中さんしかいません。
There is only Mr. Tanaka, Mrs. in this room. For a cash payment. Shit, this one is hard.
「現金払いなら」
What?
パーセント5、10%値引き
Moral math.
だけまして
What? What's the problem? 15, not 50. Shit. My town,
私の町のが住民では
では
住民の数が増している。
現金払いなら 15% 値引き
Shit.
秒
What? A second.
8から5を引いた。
What?
in
5 from 8.
in い
Or what?
秒
馬の数を数えた。
I counted the number of horses.
馬の数を数えた。
うちの子供はもう100まで数えられる。
Our children, our child can already count to
で
100.
さ、
秒小学1回
彼女は数年前に亡くなりました。
She passed away several years ago.
数秒後に雨が降り出した。
What?
秒数秒
A few seconds ago. It started raining a few seconds ago. A few seconds later. A strange sentence.
彼は100メートルを10秒で走りました。
He 100
目、
meter. He ran 100 meter in 10 seconds.
8-1は7です。
What? A minus 1 is 7.
8-1は7です。
ここへは数回来ただけです。
I have only gone here a few times. I have only come here a few times.
4+4は8です。
What?
足、
Huh? The... Why? Shit, Japanese so stupid. This means a leg, a feet, man. Why do you...
足、4+4は8です。
Shit, 4 plus 4 is 8. That's so stupid.
箱の中のリンゴの数を数えてください。
The inside of the book, or inside the box, apple inside of the box, the number, please count the number of the apple inside. What? Apple inside the box.
それは、ほんの数秒しかかかりません。
That is
ほ、
only. That will only take a few seconds.
ほんの数人の学生しか、その試験に合格しなかった。
Only a few people, or only a few students pass that test.
それは、ほんの数秒しかかかりません。は、それは、ほんの数秒しかかかりません。
数秒。
それは、ほんの数秒しかかかりません。
What?
数秒。それは、ほんの数秒しかかかりません。ません。10-5は5です。
5 minus, oh, 10 minus 5 is 5.
3+3は6です。
3 plus 3 is 6.
2たす2は4です。
2 plus 2 is 5.
3+3
Shit. Is there more? Airport. Forget about it. What should I do now? Ha ha ha. So many, man. Whoa. What do I do now? Forget about it. I don't know what I should do. I don't like object-oriented programming, man. Doesn't make any fucking sense.
Hello. I don't have a routine. I feel pressured now. This might be the most boring talk. I hope it's not, but I at least don't have a routine. I also don't have any entertaining gifts, unfortunately. Thank you. So thank you for the introduction. My name is Catherine West. My talk is called Using Rust for Game Development. And since probably a lot of you here aren't game developers, it's what you can learn from it, even if you're not a game developer. So the genesis of this talk is that on IRC or Discord, I keep getting these questions. Like, how do you make a game from scratch in Rust? I've tried, and maybe I run into the borrow checker complaining. Or I try to make a game, and I need internal mutability. Or maybe it's just like they've tried this, and they seem skeptical because they think that the borrow checker is very limiting. And I think that these are all kind of, these three questions are kind of the same. This is like beginner fighting the borrow checker. This is intermediate fighting the borrow checker. And this is advanced fighting the borrow checker. But obviously, in case it's not clear, because I'm here at RustConf talking about game development, I don't necessarily agree with these. But the trick is that you want to give an answer to these kinds of questions, and sometimes a small answer is not appropriate for a question that's about what happens when you grow something beyond the small. So this is my medium-sized. Oops, I've already messed up. This is my medium-sized answer to this question. So before I go any further, I'm going to have a lot of code in these slides, and I really am sorry if people in the back can't see. All these slides will be available online. But even better than that, I actually didn't write this talk for RustConf. I actually wrote a long-form blog post of this. This is way longer and probably way more interesting. So I'm going to make that blog post public at some point in the next week. So if you don't like my talk, you maybe will like my blog post. And if you can't see, then the blog post will be there. I think the real reason that I get a lot of these questions is that Rust does make certain patterns more painful than others. This is a great thing. This is probably my favorite feature of Rust, is that it gives me this pressure not to do the easy bad thing. And what I found is that these things that Rust kind of guides me to do are oftentimes the easiest generally, whether or not I've written in Rust. And the reason I know this is because I had to learn it the hard way. And I didn't have Rust's help. I'm going to talk a little bit about the game I worked on at Chucklefish called Starbound. I'm going to pick on myself a lot. I made a bunch of mistakes, and I'm going to talk about them. They're all my fault. It's easy for me to pick on myself. And what I should have done, like one of the things I should have done, is I should have used something like ECS design. And maybe if I'd used Rust, it would have given me the right guidance and pain to maybe pick these better designs faster. So if you don't know what ECS is, don't worry, because we're going to build one. So this talk is going to be working through a game engine from the simplest it can possibly be to something that I think is appropriate for like a mid-sized project. And it's going to have an ECS in it. And the reason that this works so well with Rust is that Rust tends to reward data-oriented design. And I might be using this term a little bit different than a lot of people use it. If you go look up on the Wikipedia page for data-oriented design, you'll see a lot of things about like cache locality and cache behavior and performance and things like that. But I don't actually think that that's like the most important part of it. And I think it has a lot more meaning for a language like Rust. But I also think that these are kind of two sides of the same coin. But we'll get into that. So what is a game? What is a video game? It's Simplest possible form. You make a game state. So this is obviously this would be very complicated and large, and your entire game fits in this one structure, right? So players, entities, monsters, whatever goes in this one structure. And then you go into a loop. So a video game, you take input, right, like from a controller. You take input, and then you run a bunch of code to update your game state based on the input you got. So if you're jumping, you press the space bar or jump button, and your player starts jumping. Then you render what you got, and you wait for the next frame. Repeat. Shoot. Sorry. OK, I need to stop clicking that. So then you repeat. So this is the simplest possible game. You can't even call it an engine. You make a game state, you run a bunch of code over it, repeat. So what can we learn from this ultra simplistic example? One, I don't necessarily recommend you make a game this way, but you could make a game this way. I promise you can make a game this way because I've seen them. I've seen the source code to unreleased games that are written this way with procedural ball of mud, 12,000 line world generation method. I won't name names, but I've seen them. And if you did it, you'd have minimal problems with the borrow checker. And a little bit of thought will tell you why. Every one of these procedures that you run over your game gets complete and total mutable access to the entire game state. So if you have complete, total mutable access, you probably aren't going to run into problems with the borrow checker because you've borrowed everything. And you can, one of the things that the Rust compiler will do for you is it'll allow you to split borrows. So if you have a structure with a bunch of fields, you can borrow one field and then mutably, and then borrow another field mutably. And as long as it's a public structure, Rust understands how to deal with that. But it has some downsides, namely that everything is in one giant, morally global, mutable megastate, right? Everything is procedural. You could very easily end up with like a procedural ball of mud where you have your input system, and this is supposed to make the player jump, but I could just lean over here and just mutate the physics state because nothing is stopping you since you have everything borrowed at once. So there are some downsides. But it's important to keep this in mind because we're going to try and improve this. But we know this can theoretically work, and we're going to improve on it. First, we're going to improve on it in the wrong way. And we're going to do it with the example of Starbound because I did it. So we're going to try object-oriented design in order to improve our game engine. So what are the principles of object-oriented design? There's the single responsibility principle, which says, OK, you should take your data, and you should bundle your data up into logical components. And then you should take the functions that operate on those components and call them methods and bundle them together, and it's called a class. Encapsulation says that the data that you bundle into a class should be private by default, and you should lean towards privacy because somebody else might mess with your data, and you might have to mess up invariants, and then that you should lean towards accessing that data through members. The abstraction principle says that rather than depending on having one class depend on another, you should lean towards depending on some kind of abstract interface, or like in C++, it would be like a pure virtual interface. And this is related to the last point, minimal coupling, which says that you shouldn't couple the design of one class to the design of another, and instead interact through these pure abstract interfaces. So let's try this and see how it works. Spoiler, it doesn't really work that well, but we'll get there. So this is kind of I'm sorry if it's hard to see back there. Again, all these slides will be available. This is kind of like the smallest possible Starbound game state. So you have 3 entities. And if you don't know what an entity is, because I'm using all this game dev jargon, if you have a world, everything that's static, it doesn't move, you can't interact with it, you can't do anything with it, but you can maybe stand on it. That's your static data. And then anything you can interact with in games is usually, they're all entities. So in this case, our entities are the player, the thing you control, monster, which may be like a little critter going around that you shouldn't touch because it'll damage you, and then maybe some NPCs that you can talk to. And then we have our game state, which is the struct that we made that's going to contain the entire state of our game.
I'm not saying that it's
one thing to
very
note
easy.
here is that our game state
it
is
doesn't make
like a
sense.
list of all the non-entity data that I talked about,
It's
and then
wasteful
this list of entities.
it's just
And we got this.
inefficient.
If you don't know C++, I'm sorry.
It's just not a
but,
good way to program,
hopefully it's not too
man.
distracting. We have the shared pointer to void because we don't
What
know
are
what to
you
put there
talking
yet.
about?
So we have entities as an NPC, a monster, and a player. So the type system is kind of in our way. So we have a shared pointer to void. And we're going to improve this in a sec. Another thing to note from this example is that one of our internal states, I have this, I'm going to use this a lot, and this is going to end up being important, but there's this entity index type. And this is actually really interesting, because this is super common in C++ game engines. In fact, I've never seen a systems programming language kind of game engine that doesn't have these. And this is a C++ example. So you might think like, okay, well this field is player ID. So like, Starbound's a multiplayer game. You need to keep a list of all the entities that are a player. But why don't you use a pointer? It's C++. We can live dangerously. Let's keep a pointer. And the thing is that nobody does this because it's wildly unsafe. If you keep internal pointers, they will become invalidated and your game will crash. So nobody in the systems game development environment, all game engines have this, it's either an ID or some kind of index or something to identify entities. And this is important because we have to do this in a lot of places in Rust, but it's the best idea. And it has other benefits like, for network serialization and file serialization. It's hard to serialize a pointer, right? But this is very common in all game engines. This is kind of an important thing. So, OK. So we had this shared pointer to void, and it really sucks because we can't do anything with shared pointer to void. So let's make this, we're programming an object-oriented. We're doing object-oriented design, right? So let's make this interface called entity. So let's very quickly think of all the things that will be common to every single entity. Position? I'm done. I can't think of anything else. You might, in our example, all of the player, the monster, and the NPC all have velocity. They all have physics, but maybe you have a stationary entity. It turns out that, maybe you have a stationary entity. It turns out that there's not very much in common, almost at all. So Starbound actually has an entity interface like this, and it's filled with a bunch of methods that all return basically option, because some entities don't have them, and then you're kind of defeating the purpose of having an entity interface. But anyway, but one thing we can do is we can give them methods. So we're trying to do object-oriented design. So let's say that every entity can handle input state. So like a player might start a jump if you hit space, and then every entity has to update themselves, and they have to take in the rest of the game state. So like if you're a monster and you're tracking a player, you have to know where the player is, because you have to maybe know where other monsters are. So you need the rest of the game state. And then they could render themselves somehow. We're not really going to talk about that. So then the player, implements this interface. The player has a position. They handles input, handles update, handles render. Monster and NPC are exactly the same. And now we can keep a shared pointer to entity instead of a shared pointer to void. OK, this seems like it could work. New requirements start coming in. So you make a video game. You're constantly going to be experimenting, constantly going to have new requirements. Monsters can track players because they know the player's position, but they should track, because it's a multiplayer game, they should track the player that has the lowest health. All right? Well, health is private to player because we're practicing encapsulation. So that's OK. We'll make an accessor. Not a big deal. More requirements start coming in. The monster should not go after players who are marked as admins. So Starbound's a multiplayer game. We have this concept of admin. It's not super important. But so, OK, we can make more accessors. Not a big deal. Well, admin is admin. No problem. OK, well, we have to continue on with development. So we need monsters to start damaging players. So if a player gets too close to a monster, it has some kind of geometry around it. And if the player's geometry overlaps with the monster geometry, the player should be hurt. Well, OK, so let's think about this. Where do we put it? We're doing object-oriented programming, so we should take our methods and apply it to the place that it makes the most sense to go. So I guess the players damage themselves. But you could also say that monsters do the damaging. They're the thing that does it. There's not actually a great place to put it. So we can pick one. We'll just pick player. Players damage themselves. The player will check its own bounding box with that of the monster and will decrement its own health. If we did it the other way, then monsters would have to have access to players' health, which, like, mutable access, that doesn't seem right either. So we'll do it this way. And we need more accessors because, now the monster has this damage region and the player has to check it. So one more accessor, it's not a big deal. OK, so you're making a stealth game. And if the player walks next to a monster and they're on the ground, the monster might react in some way. That's no problem. We'll add an on-ground accessor to player. Except we've been practicing good object-oriented design, and our player has this sub-object, right? We know that we shouldn't use inheritance. We've been told that a lot. Inheritance is how we should use composition.
This is why I don't like
so we composed our entities with this physics object.
Keep getting more complicated
and only the physics system knows whether you're hit on the ground. Not a problem. We'll add accessors to physics, and we'll add an accessor to player that just passes on to the accessor to physics. And as you can see, that you kind of need more and more of these. And then the more you do these patterns like composition, the more accessors you need. How many could you possibly need, really? Well,
let me see.
This is the for real, actual Starbound player class, copied from the Starbound source code as of the latest version. You can tell that we've been following good object-oriented programming, and we've been using a whole bunch of these pure virtual interfaces, because you shouldn't have something depend on the player necessarily. You might have something else that can emote. I think there's 8 or 9 of these. There's actually more like 35 of these interfaces inside Starbound. There's a bunch of them. So let's just quickly go through all the accessors in this class. So
a lot of code to do.
You gotta know how much energy the player has. You gotta know how much breath they have, their protection, whether they're forced nude. What kind of game did I make?
Completely unnecessary.
Okay, that's for something. I know it's for. It's for like the player creator or something like that. And if you're nude, you just want to be nude. It keeps going and going and going. Whether they're an admin or not, it was up there somewhere. I don't remember where it is. Is admin, yeah. Oh, whether they're dead. That sounds important.
I will get a copyright strike for this.
Okay. There's like 400 lines of these.
For what purpose?
The number of methods to the player class is like 200 lines longer than the number of members in the player class, somehow. I don't know. This one's great because this is some like sub-object for like the ship's AI, and we just gave up. And now like, you can get it, immutably. It's an accessor, and also we need to mutate it, and I'm tired of writing tired of writing methods. So we just like, there is literally no difference between this and just a public member. Don't do that. Don't make games that way. But we're going to try this in Rust anyway, and we're going to see what we can learn from it. And what you're going to find is that this kind of design fails quicker. And there's a reason for this. OK, so we start with the simplest object-oriented C++ version. We have an entity interface, and we have our game state, list of entities. We're going to translate it to Rust. Now we have an entity trait. Ooh. And a list of entities. Very quickly, this vector of option. We have a box entity because it's a trait, so we can't keep a direct copy of it. But also, just so you know, like there's this option here because I'm keeping a vector of entities. So you might remove an entity and the option becomes none. Then you allocate a new entity. You have to go find a none to put it in. And then the rest of our game state. So OK, right away, this is already wrong. This is already broken. So an entity tries to update itself, right? It gets a mutable reference to self and a mutable reference to game state. Even if it got an immutable reference, this would still be a problem because an entity gets a mutable reference to self, and it's also inside the game state. All of our data in the whole game is in this game state. That's mutable aliasing. You can't do that. So right away, we try to make a method, and it doesn't work. So there's a bunch of ways you can solve this, and most of them are really bad. You could do things like remove the entity and then call update and then put the entity back. It doesn't work. The best thing you can do, which is bad, is to try interior mutability. So we have ref cell. Now all of our methods take immutable references to self. And this sucks. If you try to do this, you go on IRC and you say, why do I need this? Rust sucks. I need ref cell. You're fighting the borrow checker. It's helpful, but not necessarily helpful. If you've ever found yourself in that situation, this talk is for you. So it gets worse. Say you have this entity trait that's pretty sparse. This is something that actually shows up in Starbound. You have these we have a tag system. We have everything in Starbound.
Wow.
We have this tag system where
What's
you
the
can
point of
get a
this?
list. Maybe in Starbound it's like a list of strings.
This is just
this tag method. I've unalighted the lifetime, so it's clear. But this borrows the whole entity, no matter what, and returns a reference to tags. So already this is a problem. That's a lot of borrowing. And maybe if you want to get the tags from an entity and then do some operation that involves mutating the world, maybe that's a problem. And it's even worse because if you need internal mutability, you can't return a reference. You have to return a ref cell ref type, right? This is really hard. It gets worse. The larger your game state, the more you borrow. So we have the game state. In Starbound, it's like a 2D block-based building game, right? So we have a method like this in our version of this, where you get a block based on some integral index, and it returns a block. Well, unalighted, this borrows the entire game state. This is a problem. You don't want to have to call clone. You don't want to borrow that much. But the fact that everything is private is getting in your way. And this is worse with traits. So I mentioned this because Starbound has this as well. We have our world class, which has a million methods in it. And there's a world server and a world client. So if you're the server, you talk to a world server, the client talk to a world client, and they both implement this interface. And I'm trying to improve the performance of Starbound. I've been doing a lot of perf work. I need the world to return a reference.
The hell with you.
Everything is terrifying. In C++, this is use after free. In Rust, it borrows absolutely the entire game state, and you can't do anything, and you're forced to clone it. So it's not very helpful. So what are the takeaways for this? This is kind of common knowledge in the games industry, actually. But in case you haven't heard, object-oriented programming kind of hurts more than it helps. And this is kind of insidious because in a game, you have these objects, and it calls out to you, right? What's an object? Well, player, that's like a physical object. Monster, block, right? And these sound superficially appealing, but if you keep going, it's actually quite harmful. Most of your concerns end up being cross-cutting concerns. Things like damage or collision, right? Multiple entities collide with each other. It doesn't make sense to have a collide method. And this bad design that we talked about fails quickly in Rust. You start getting pain points. It's like the Rust compiler is telling you that maybe this is not a good idea. And one of the takeaways is that
Khoan, từ từ để khoe cái comment này. Đâu rồi? Oh shit! Tại sao comment bị tắt rồi?
The old woman was always angry with her.
Tự nhiên comment hay ho người ta tự nhiên bị xóa mất luôn. Không thể nào khoe được cái comment 4.000 mấy like hết. Shit. Khó tìm mấy cái thông báo cũ quá. Đâu rồi? Comment này chỉ có 300 mấy like.
find it helpful to force
YouTube hơi chơi cái trò mà xóa lung tung video quá. Làm có mấy cái mất luôn không thể nào tìm lại.
myself to think about things as just data, like to think in a data-oriented fashion. And by that I mean just concentrate on the reference. Representation of my game state, and don't conflate the methods that operate on the data with the representation of the game state, or the state of whatever you're doing. Okay, so this is a bust in Rust. Let's go back to the beginning. So this is kind of a Rust version of our first data model for Starbound. You have a player entity, you have a monster entity, you have an NPC entity. They all have some physics. So like, we're not going to do the shared pointer to an interface thing, or we're not going to do box entity. Let's instead use an enum. So this is all of the kinds of entities we have. And then in our game state, we just keep a vector of these entities, which are either a player, monster, or NPC. And then we have this basic update structure that we had before. So cards on the table, this is fine. If you're making a game jam game, probably stop here. You know, if you want to use an ECS, that's fine, but this is not so bad. Like, especially for small things, right? Like, yeah, your entire game state is available to everything, but it's actually fine. So I wanted to mention this because I'm going to explain a couple of steps beyond this, and each one of them might be a stopping point if you wanted to make a game engine from scratch. So one thing I wanted to point out, though, is that, see this physics system? So the physics system needs to go through every entity that has a physics member. So, but here, there's this enum here. So all entities have physics, or maybe even most entities have physics. We add more entity types. But it needs to the physics system needs to understand every single entity type. It needs to match on the enum, and then see, it needs to know which of them do have a physics type, or it won't compile. And you have this it's not that easy to like deal with a subset of entities that have the same state. We can fix this though. We can unify our entity type. So instead of having an entity be an enum, we can take every state that an entity has, and we'll just shove them all in one big structure. So most entities will have physics, but this is an option physics, and then entities might have health, and then we have all these like player, monster, NPC like types that were there before, but we're just like, if you're a player, you have this set. If you have a monster, you have this set. This is useful. But what's even more useful is if you generalize this a bit. So before, a monster had a current target, right? Like in this slide, a monster can be aggressive towards some kind of player. Well, here we take this out and we make it its own little state. So we've just kind of generalized our fields a little bit, and sometimes you can't do that because we still have stuff that only makes sense for a player. But this is kind of interesting to think about because it's a give and take, but this allows you to express more states than the previous one. In this, you can express an aggressive NPC. And maybe that's good. Maybe you would want that. But you can also express an aggressive player by setting the player setting this field and then also setting the aggression field. And maybe your engine just doesn't know how to handle that. Maybe that doesn't make any sense. Maybe aggression only makes sense like if you have an AI system and the player's not run by AI. So it's important to remember that this is powerful, and you can do this, but it's a give and take. So you can go further, and this is usually the part where, if you're reading an explanation of what an ECS system is, they focus on, because they look at this as purely from the lens of performance. So this is kind of confusing, so let's go back. We have this entity structure with all these optional fields, and then we have this vector of these entity structure. We're taking it, and we're saying that instead of having a vector of structs, we're just going to have all of the vectors for each of those parts in one top-level structure. This is kind of called the array of structs to struct of arrays transform if you're into data-oriented programming. And we're going to do this transform, and we're going to do one more thing where we give all these parts a more informative name. We're going to call them what they are, which is components. So if you've been paying attention, we now have entities and components. And our systems are just these procedures that operate on a game state. So we're getting close, right? Let's see. What are the takeaways so far? Thinking about the structure of your state is really powerful, and not thinking necessarily always about the methods you've decided to apply to that state. Another takeaway is that you can do a lot with vex and indexes into vex. The reason I mention this is because I see this a lot, actually, not just in game programming, but because with applied thinking. So let's see, right? Let's see. State the method do a lot is because you need like to make a graph structure or something, and you need to update it. And you go online, and people give you advice about like using arena allocators or like RC and internal mutability, and those are great. And those tools have their place. But seriously, just put your nodes in a vec and use indexes. It is so easy. That should be the first tool you reach for. However, it still has some problems. So if you do that, and I do that, when you get an index to something in your vec of members, or your vec of nodes, or whatever, if it's a graph, and you delete one, that index is still valid. And if you think about this, this is kind of like use after free. Like if you can think of your indexes as kind of like pseudo pointers, if you free a node, like if we freed an entity and then used an entity index to get that, to get that entity, hopefully we would notice that it was gone. But if we allocated an entity right afterwards, then we might not notice that it's gone. We might get a random other entity, and it's safe, but it's not great. We can solve it. So this is a pattern that is super common in the game dev community, and I don't think enough Rustaceans know about. So I included it in my talk. we're going to talk about generational indexes. And a generational index is just this index we were talking about, like entity index with one extra field, which is called a generation.
Oh.
So if we had an allocator for such a thing, we might allocate a generational index, and it would give back like a 0 with a generation of 0. Allocate another one, it gives back 1 with a generation of 0. Deallocate the 0th index. Allocate another one, we get back an index of 0. So still all of our indexes are small, and we can store them in a vec. But we never repeat. Our invariant here is that our generational index allocator will never return an index that is ever equal to a previous one. I mean, unless you make this generation overflow 64-bit ints. But if you can do that, your game technology probably has cloud in the name, so you probably have bigger problems. But these are useful because they solve this this use after free problem of indexing. And to go a little bit further, we just need one more thing, which is this generational index array, which is just like an associative array of these indexes. So instead of a vec, it's just like an easier version to deal with than vec of option of t. You can set values based on a generational index, and if you get them out, crucially, if the generation must be up to date. So if you have an older generation, you get back a none. So putting it all together, instead of having these vec of options, we're going to have this entity map, which is just a type def of this generational index array. And then we're going to rename entity index to entity, because it's no longer, we don't have to worry about it anymore. There is no such thing as an entity anymore. So entity index, entity ID, we're going to call this index entity, and we're going to keep all these entity maps of all of our components. This is an ECS system. Takeaways. Generational indexes are awesome if you don't know about them. They solve a whole lot of the problems of regular indexing for doing this internal mutability. There's a crate for it. It's called slot map. And I couldn't use it in the talk, even though I really, really wanted to, because it's missing a key feature. You can't, in slot map, allocate these indexes separately from using them. You have to bundle them all up, and it gives you kind of a structure, but you can't allocate the indexes separately. If you're the author of the slot map crate and you're at RosConf, I am super sorry for calling you out on stage. But I have another version of this. I can release that as a crate. That sounds like a threat. If you don't make this change, I'm going to release a competing version. I didn't mean it to sound like a threat. So okay, one more transformation, set of transformations, and we're done. So dynamic typing. Everybody loves dynamic typing. It's great in very tiny quantities. But first, we need a type. We need this structure called an any map, which is great because there's a crate for it, and it's not missing any features, and I don't have to call anybody out on stage. So an any map, very briefly, is a map, it's like a set of types where you can store exactly one of any type. So you can put a t in, and then if you put a t in before, you can get it back out. It's just that simple. So this is where we were before. And we can see, every time we add a component, this list is going to grow. And what actually will end up happening is we're going to list all of our types a whole lot, and we're going to find a pattern to deal with that. But just in this is one instance, all of these components, adding to this list, can get tedious. And every time we add, we are potentially touching a dependency of every single system that we have. So let's keep them in an any map. The type system stops being helpful when you use dynamic typing. So we're going to have these entity components, but they're just these collection of entity maps of type T. And let's go even further, and we'll keep all of our non-entity data in an any map as well. And we'll call those resources. And we'll change our name from game state to something more informative. We'll just call it what it is, which is an ECS system. We have these any maps. The type system stops being helpful. So you might have an interface like this. So you can get a component out based on some type T. You can get a resource out based on some type T. And we've added these component and resource traits, which I'll talk about in a second. But this is an ECS system. You might balk at this like sudden introduction of dynamic typing. And you would have a point, kind of. This is not vastly better than what came before
quite understand this.
until we add one more pattern. And I don't, this is common like outside of Rust, but I actually don't know what to call it inside Rust, so I'm just going to call it the registry pattern. So we're going to make a registry for all of our components. So we're going to have this structure called a component registry, and we're going to call register component for every single component that we have in our whole game. And we're going to do the same for resources. And you know, we have to keep a bunch of stuff in here, like you know, box functions, and it gets kind of gnarly. But if your component has, if this component trait has methods on it that allow you to like load from a file, what you end up being able to do is you end up being able to have these methods on your registry that says, hey, go take an ECS and put every component that we know about in our game in the ECS.
Wow.
And then you can also do this where this like load entity, say your component trait knows how to load from a JSON blob, you can say, hey, go load an entity into my ECS based on this config file. So this might be like some kind of array of all of the components, and then it gives back the entity after adding them all. And you can do the same exact thing for resources, where you set up all your resources, and then you can load any given resource. So then, because everybody loves globals, we can take all of our registries and put them in a big top-level registry. This is, I'm joking, but this is actually fine, because I mean, this is kind of like enterprise-y, but you know, you might have seen something like this even in like Java, where you have like a list of all your types. But this is actually super useful to be able to say at any moment, like you have this global registry that knows about all the types in your game. And then you can have these functions here, like load component registry and load resource registry. You can put those in, like, if you have a component / lib.rs that lists all your components, put the component registry right below it, and you can list all your components, right? So this is a super useful pattern. So what are the takeaways here? Dynamic typing is powerful and useful, but obviously you need to be careful when you use it. But if you can use it in just the right place, you'll notice that this has kind of solved the last problem that we had with our super simple game design, right? So you declare all these systems, right? And you know, we had this problem where every time we added something to our ECS state, we would immediately be messing with the dependencies of every single system. But now, a system can only know about a part of our game state if they know about that type. So you can just look at the import list for any given system and see whether it depends on something. And it breaks up this everything is depending on everything else not. If you need dynamic typing like this, usually you'll have something like a type registry to go along with it. This pattern is super common. In object-oriented programming, you might call this a component factory, but if I said iComponent and component factory, I would rightfully be laughed at. But oftentimes, these patterns in object-oriented programming are really complex, and any map kind of simplifies this. You know, if you're going to have dynamic typing and downcast, just kind of own it. Just put everything in an any map. And any map is awesome. Let's just wrap up here really fast. Let's see what time it is. I'm a little over. You know, I didn't talk much about the performance implications of things like ECS systems, and I kind of did this on purpose because I've read a lot of really confusing ECS explanations, and I think that they can kind of lose the larger point, which is that like it's very useful and powerful to just stop thinking about objects sometimes. And I also think that, you know, you have things like data-oriented programming, which are classically just thought about just for the reasons of performance, that this is actually kind of more important for Rust because Rust has this focus on like ownership and borrowing, and then the data-oriented design can both make for better performance and also for an easier time with the borrow checker. And critically, these are kind of two sides of the same coin. I apologize if you've heard a lot of this before. I feel like I'm kind of retreading old ground, like especially in the game dev community. If you hang out there or are interested, you know, a lot of these things are kind of considered common knowledge, like ECS design and the fact that object-oriented programming is overrated. If you have heard them, I hope that this is maybe a simpler explanation that you've gotten in the past. And I hope you've, if at the very least found some good design ideas or some good features that you may not have known about or may not have thought about otherwise. And also, just to finish up, there's a lot I didn't talk about. I didn't talk about all the great crates. If you actually want to make a game in Rust, don't write your own ECS system. Go use Specs, right? Specs will do all this, and it'll schedule your systems, and it'll have great performance. And don't make your own ECS system. I just wanted to explain it. But also, there's other ways to make games. You don't have to use an ECS system. You can use the actor model. There's lots of great ways to make games. I was not able to talk about all of them. And that's it. Thank you very much.
Very good. Shit. Nothing new. The hell? What? that look a bit weird. The hell it is? Where is this from? The hell? Nothing found. The hell is it? Forget about it. What? What version is this? Hmm. What? This is not enough for me. Is this really a good method to do that? Is it necessary? I don't quite understand this. where this trend's coming from. Entities. Person and position. What? Translation and rotation. What? What the isometry tree mean? I don't like using float. It's all integer for me. The hell it is? Huh. Everything seems pretty complicated. texture, sound. What about 3D? What's the point of any of this?